And we're live. Welcome, everybody. We'll wait a bit longer to let everyone roll in, and also to let our speaker roll in, Kaspar, who's currently having a couple of connection issues, I think, is restarting the browser, but should join us soon. So welcome for the Easter special. I hope everyone is... Hi from Germany. Hey, Kaspar. There he is. There he is. Perfect. So now we're officially live with the speaker, which is a great start. So I hope everyone had a good, fulfilling, restful Easter break. As I've been doing for the last, as we wait for people, I will spam the current attendees, as I've been doing for the last couple of events, using the chat functionality that Wolfgang already is using. Hello, Wolfgang. And I'll share here a link to PlatformCon for the ones who haven't seen it yet. That's the first platform engineering conference that we're going to run in June this year. So first ever, really exciting. There's an incredible lineup of speakers, and it's free, fully free, 100% free, 100% virtual. So go check it out. I think we can almost get started. Just same housekeeping, session is recorded, and we'll share it tomorrow with all the notes and the slides and everything else. So don't go crazy on note taking. I think Kaspar is going to talk about our latest Kubernetes report for about 20-30 minutes, then open it up to Q&A. If you have questions while we go through things, just feel free to drop them using the chat functionality, or there's a Q&A functionality. And we'll make sure that we'll get to those as we go, or at the end on the Q&A session. And I think with that, there's a good number of participants. So Kaspar, over to you. I'll disappear from the screen.
Very quickly, Luca, can you hear me well? Otherwise,
I can hear you well. Yeah.
I have a backup. Okay, so there's a little bit of strangeness in my network, but I have a backup, and if the need should arise, I can always fall back on that. It's suboptimal conditions because my voice is also trying to escape me, but I'll give my best, and I'm very happy to be here today to give you an idea of what we found in this Kubernetes study, which I personally was very much looking forward to, given the fact that there is so little information out there about the actual usage and how people approach that. I've always had a lot of questions, and so I was one of the more pressing forces behind making this possible here. So as you are probably familiar, we run a good amount of different studies. There is the DevOps maturity benchmarking, has made quite some waves last year. It's coming up this year again. We have this Kubernetes one. We have one for infrastructure as code, which is super interesting. And I have like too many slides and too much to tell you, so I think we'll dive right in. You can ask questions at any point in time, and you can and Luca will monitor them and then decide whether he will interrupt me and weave them into the conversation. About me, really quickly, I've been doing this shit for the last 10 years. I have a focus on platforming, and I'm basically doing nothing else. I have a small family and 2 children, and everything else in my life is platforming. And so I'm really happy to be here today, and you can reach me by email anytime, Kaspar@humanitec.com, or Twitter is a little ridiculous Kaspar official because everything else is taken. But yeah, reach out to me. I'm always happy to chat. Yeah, with that, what we surveyed 1,100 teams. I think it was 1,090 something. And what we want to go through today is what we learned from these teams. All right. So if you're familiar with the way we do benchmarking, you probably know that we are always giving scores. Now, these scores are between 0 and 100. And if you are like state of the art, absolute elite team, you score everything, then in this benchmarking, and by the way, this benchmarking runs for weeks and months across EMEA and the United States, primarily on Twitter. And so we see all these participants. So if you score really well, you get 100. If you don't score that well, you get 0. There is always some discussion like how much can you put the score to that? And the score is honestly more like a sorting algorithm for us, if you want. Like we want to have a basic idea how you relate to other setups. What we can see here, as we've plotted the score, is that we have again this mountain. You can see that there is probably the weight of the distribution here in the between 50 and 75, 80%. And what we found interesting is that again, and that was true for most studies that we do, pretty consistently, there is this chasm, if you want, and it's really hard for teams to cross that. Now the question is, how do you actually get into this field here? All right. So the first thing that I want to look at, and we will go through the different findings now really quickly. And then what I actually want to spend most time on is going through concrete things that I observed how teams do that. Has a lot to do with abstracting without abstractions, without abstracting, that I see in these high-performing teams. And I work with quite a few of them. I have a focus on the US West Coast. So I mostly work with these teams at the moment. And I want to share a couple of insights on how these teams actually nail their Kubernetes implementations. This will be a little technical and it will be different to what you usually see. So I think it's worth sticking around. But before we go into that, let's actually look at the implementation state of Kubernetes and a couple of the questions that we found. All right. So this is not that much of news. The majority of services of top performing teams are now running on Kubernetes, but you would be expecting to find that because it's a Kubernetes benchmarking test. But you can still, so I think that the relationship between top performance and low performance is more interesting. But even there, you can see that now most of the services are on Kubernetes. That's something people get consistently wrong. People think, Lambda, serverless, all of that is the future. Look at the list of usage of Amazon Web Services. Lambda and serverless is very on the bottom. In the 250 teams I spoke with in the last 12 months, 4 of them had a majority serverless strategy. The new legacy is indeed Kubernetes. I think there is no way to not use that statement. Kubernetes has its downsides. It's probably not what we'll be using for the next 10 or in 10 years, but for now, that's actually the new legacy really. All right, let's go into more. Here, I find that interesting. We asked, did you underestimate the complexity of Kubernetes? And that is actually like a really consistent pattern. And if you are currently tipping your toe into the Kubernetes world, I would propose you 2 or 3-fold the time that you are putting into forecasting right now for the implementation, because it is really complicated. It gets more complicated if you try to run Kubernetes yourself, because then you also have to prep your operations team. It gets more complex if you have to deal with if you're not dealing with a managed service like I don't know, EKS, GKE, AKS. But Kubernetes is a pretty complex piece of technology, and it requires a lot of new engagement methods from your colleagues. Now, I like that one a lot, and it's a little random because it was really a free text format and people could put in whatever they want. And we dissected everything and tried to bring this together. Unfulfilled expectations prior to adopting Kubernetes. Some are pretty straightforward. I mean, cost saving, seriously. Kubernetes can be fairly pricey. And again, we see these easy to use, easy to maintain. 7.5% thought it would be more cloud agnostic. That's really interesting. If you don't nail configuration management with Kubernetes, it's not cloud agnostic at all because you have all of those references sitting in your Helm charts. And what I find interesting here is actually standardization. That's a big one. I was expecting that to actually be larger because Kubernetes has, if you do it right, a vast potential to standardize the setup that you're running. If you're getting it wrong, it has a vast potential to de-standardize, if that is a word. All right, let's continue. Technical challenges and best practices. DevSecOps, that actually made me very nervous. 37.5% of respondents store credentials in their repository. Not a very good idea. 27%, and in 9.6%, they're even hard-coded. And that will probably, the shadow number is probably higher. But yeah, I'm not sure how you do that with all of the code scaling tools around, but probably not a very good idea. And then 27% are using secret managers. But there again, you can see the complexity. Setting up Vault, if you've done it, is possible, right? But it's just another thing that you have to invest in your time and figure out. Okay, now then, we're getting into the little more technical bits here. Are your application configurations stored as code? Low performers, that is actually not the case in 34.2% of cases. And I'm seeing that myself astoundingly often, that people actually do change by change requests again directly against kubectl, even in environments that are fairly security concerned, and that is probably a fairly a rather dangerous thing to do. 53.4% of cases actually do that, and you can clearly see top performers, but that's more like conventions. 98.4% that are completely using configuration as code. How, also interesting, the front runner everywhere is Helm charts, obviously, with 49% of the top performers, 45% of the low performers. And then the second one that you hear is Customize, where I'm seeing initial usage of Customize and then a lot of migrations back to Helm. I'm not a tremendous fan of the technology or like the spec, but it's still a lot in use. And then other tools is pretty low, so we have this consolidation on those two. One of the things that we will cover in just a second in more depth is that one of the key recommendations for me is to separate out environment-specific configurations and environment-agnostic configurations. If we talk about an environment-specific configuration, that would be like let's say, connection string to a specific database. And if we look at an environment agnostic configuration, that could be that you want a CPU minimum of 0.5, right? That could be the spec that has nothing to do with the specific running instance, but you, but it's really agnostic. You could reuse this across several environments. We're seeing that in use here in 75% of the top performers. And that's something that I want you to keep in mind, because we are going to revisit that in just a second. That's a very interesting detail. In general, the key secret to nailing Kubernetes lies in the configuration management. And it lies in the way you think and maintain those configurations, just so that you have that at the back of your head. We'll be going through this in more detail. Now, provisioning infrastructure and managed services. That is something that we've asked in lots of surveys. You can see that Terraform, so managed as code, is the predominant option for the top performers. But and you can see, obviously, that's also what I'm always saying. The low performers have a problem because they have ops do things on a bit by bit basis. They have a very centralized operations team, very little developer self-service. That's always a mistake. We can see that here in particular. I mean, we can see that is also pretty consistent. Nobody seriously lets their team dial into cloud consoles a lot. Some give that as an option, but if you actually look at how much teams do that, you can see that this is a pretty rare occasion. All right. Now, I want to look at team setup and cultural aspects. And throughout all studies, that's the section that has actually shown the most fruitful insights. On the other sections, we've surveyed a lot more questions. I encourage you to read the report. I'm sure Luca will send that afterwards. But yeah, team setup and cultural aspects are usually the most important and interesting ones. I want to, we'll look at some more obvious ones, is documentation of Kubernetes set up in place. What we mean by that, is there a central team that have set things up and then they've recorded Loom videos to actually show you how that's used? Now that's the case in top performers and it's not the case in low performers, and it's in line with expectations. I'm not telling you anything new. The better something is documented, the easier it is to use, obviously, but you might not have the resources or you might not have the time to do that. So yeah, that's a little bit of a obvious thing here. Then the visualization of the Kubernetes setup is in the majority of top performers have a visualization in place. That's any of these, Kubernetes control planes where you can look into what's running where, what's the CPU allocation, spin up a namespace. I'm not a big fan of them. You can see clearly that top performers have that. In my reading, that does not necessarily mean the Kubernetes implementation is more successful. I'm not a fan of ClickOps. I think that it abstracts developers to a degree that this isn't healthy. And you can actually see that the top performers, they have full visibility into everything. They're not hidden away by these visualization dashboards. I think those visualization dashboards are usually brought by product managers that feel uncomfortable looking into the code representation. And that means top performing teams tend to have them. But in my opinion, they're not actually the drivers of a successful implementation. They're more testimony to the fact that these teams have more resources, frankly, and their shit together. And then we have the onboarding time for new developers. You can see that this is also pretty consistent. Top performers are obviously much faster in doing that. And you can see that here, some developers take 2 months or longer in the low performing bucket to be onboarded. Then this is another thing, new namespaces for feature or preview environments. Again, I think that is more like a high level observation. If you can do that, that is great. I don't think it will actually move the needle, but what we can see again is that you have less, that this is more testimony to the fact that developer self-service is possible. Now, we'll get to that, but one of the wrong ideas about developer self-service is that means developers do everything. In a good self-service setup, developers are actually really restricted. Or restricted is the wrong word, actually. I shouldn't use that word. They're abstracted. But they're abstracted without being abstracted, because they can dive deeper and understand exactly what's going on. Something you cannot do with ClickOps, something you cannot do with an extreme restriction. But we'll get to that as well. Now, this is interesting, who can deploy to Kubernetes clusters for different staging. you can see that, again, high dependency on senior operations or senior developers. This is usually something that you see. Everyone can in theory deploy, but are scared of screwing things up. Excuse me. So you can see what I call shadow ops. Shadow ops meaning that you roll out Kubernetes, you say, hey, you're responsible for this yourself. And then certain functions, usually senior backend developers in your team, specialize on one certain element, Kubernetes in this case, Terraform is another classical example. And then if all of the colleagues have any problem, and that goes down to, hey, can you please add an environment variable to the Helm chart? They will actually call that senior colleague and they'll do it for them. Well, then you end up with shadow ops, really sucks, complete disaster for your productivity. But that's actually what the data is telling us here. All right, this is interesting. How many developers are exposed to Kubernetes, right? In the low performing bucket, you can see that all of them or most of them are actually directly, and you can see a more variability in the low performing bucket. Put that together with the next one, how many developers are Kubernetes professionals? And you can see that this now is the complete opposite view here on the top performers. You saw that all of them or most of them are actually exposed to Kubernetes. You can also see that only a handful or only dedicated teams are actually experts in Kubernetes. And that is, I think, one of the key learnings that we have to take away from here. Top performers have found a way of exposing people to Kubernetes, give them the flexibility, let them take all of the benefits in terms of customizability. And frankly, if you use Kubernetes well, you can go super fast, right? And you want to preserve that. At the same time, you do not want to have everybody in your team become an expert. My friend Aaron built a platform at Salesforce, and he's always saying you shouldn't use or you shouldn't need 1,000 Kubernetes professionals to run your Kubernetes setup. That's very, very, very true. You need a few, right? You need a handful, but not actually that many. So this is where I actually want to pause a little bit on the data side. And I want to chat about what we can learn and what we can derive from just the numbers that we saw here. And if I look at this, there are two key things that I think we can take away. The observation, and I just want to phrase this again, top performing teams manage and set up Kubernetes efficiently, yet not all of them are experts. And I want to dissect how that is possible. And the view that I'm going to share you is one that is biased because of the teams that I work with. But I want to share how the most successful teams I've worked with are actually utilizing that. And there are two key things that they do. First of all, they abstract without abstracting, which sounds absurd, but I'm going to go through that in a second. And then they're platforming, right? And platforming is a buzzword these days. You can Luca is throwing platform con at you, and it is completely absurd how many thousands of people are joining there, and we have there is Slack communities, and everybody's talking about platform. But if you look beyond the hype, there is actually a lot to learn from that. All right, abstracting without abstracting. Abstract without abstracting, for me, means building layers of things that the developers are directly confronted with. And these layers, high-level abstractions, are represented as code. And they, in combination with lower level libraries or baseline templates, form the actual output. That will sound very abstract and it will not make sense at all. But I'm going to derive this in just a second. Now, actually, So one of the key mistakes that teams, especially platform teams, did for a very long time was that they said, oh, all of that is too complex for developers. We have to shield them away from this complexity. If they want to do something, we'll give them this very opinionated approach. Now, the problem with that is a little bit like language recognition with Siri. If you recall, Siri really sucked 5 years ago, although it had a 95% accuracy. But us humans, we hate those 5%. So in AI and in NLP, you usually say you want to reach 98, 99% in an algorithm for a human to actually feel like it's helping you. Now, the exact same thing applies to abstraction. If you want to get to a point where your developers use Kubernetes without being an expert, you have to abstract. But if you abstract the wrong way, well, then you could very well just let them use Heroku, or you can let them use any ClickOps tool. They will hate that. We're seeing huge revolts against that, because those remaining 5% are actually what differentiates and what makes people like an experience or dislike an experience. Now, abstracting without abstracting means that you give developers higher level abstractions that, in combination with lower level baseline standards, form the actual representation. But you help people understand in detail how the specific action that they're currently taking results into the running system. As an industry, we should spend much more time optimizing the observability aspect of the developer workflows. We're spending a huge amount of time on testing, test coverage, everything. Like, we're not spending enough time in observability. And abstracting without abstracting means making sure developers know exactly what's going on at any point in time. Okay, let me make it a little more tangible for you. So let's say we're a workload. We're the workload product catalog, okay? Now, how do I now configure that workload to run on Kubernetes? A couple of options, right? I'm open for suggestions, but we could use direct changes with kubectl. You can do that until you have the first case of disaster recovery gone wrong, and then you need disaster recovery. So let's just park the option of kubectl for a second. So then we're back to configuration as code. We can use Helm charts. We can use customize. The problem is these things are, they have a couple of problems. They are themselves have a tendency to become extremely complex. And people always say, it's not hard to write a Helm chart, right? And it's not hard to write a Helm chart, that's right. But if you have a Helm chart with a life cycle of 2-3, like with a lifetime of 2-3 years, and you have people adding environment variables to the values YAML file, those things get fairly hard to read and digest, and they get really uncomfortable to maintain. Also, you have to understand all of those things and turn this on and turn this on and turn this on. Now, the second problem with Helm charts is you basically have one for every environment, which means that anytime the environment changes, you have to do, and that is actually configuration drift between environments, the #1 change failure reason for systems running on Kubernetes. Now, abstracting without abstracting means, or could mean, as one of the implementations that I've seen work well, to define something that is a higher level spec, if you want, that describes how the workload connects to its surrounding workloads, to third-party resources like databases, DNS, file storage, and you describe that in a way that is environment agnostic. That's the next thing that that we learned. If you recall, I asked you to remember that, and I hope you did that. Top performing teams in 75% of cases actually separate out environment agnostic from environment specific configuration elements. Now that's exactly what's happening here. We are isolating the environment agnostic elements of configuration. Now, the product catalog workload will connect to a Postgres database in every environment, right? It will probably connect to different databases in differing environments. But the fact that it's a Postgres it's connecting to, that is the same. So if a developer feels uncomfortable actually managing the whole stream, you could very well let the developer work in such an cloud agnostic workload specification. Now, I've seen these cloud agnostic workload specifications set up in many different teams. And that is a practice where the platform team comes up with how to actually structure this. Now there is this new project, course.sh, where a couple of people in the industry are working on consolidating this into a format that actually can be reused more universal. But it doesn't really matter. You can actually really easily build that abstraction yourself with reference implementations, something that I'm seeing a very common practice in these high-performing teams. Now, in itself, that will not work, right? If you execute this YAML file, nothing will happen. So you'll now need to combine the environment specific elements of configuration and baseline configurations. And this is where I'm seeing the module of the model and the approach of baseline YAML files used a lot. So what you would actually do is you would go ahead and you say, okay, I'll define a baseline YAML file that can be chosen per workload, and where I define certain minimum things. That could be CPU minimum allocation, the fact that HashiCorp Vault starts up as a sidecar container. It could be things like labels and annotations for Datadog, whatever you want to have, you can put in here. And you can match what database types you want for what environment, and all of the environment specific elements of configuration could come in, could be added here, but only for the environment agnostic elements. All right. Now, then what happens? The developer can see this, right? And that's what I mean by abstracting without abstracting. They see all of that. They can go into the Helm chart with, so the baseline YAML file is nothing more than an empty Helm chart, if you want, in most cases. So those Helm charts are open. They can go in. They can send pull requests. They can add their own ones. And then, but the developer usually then focuses on this cloud agnostic specification. Now, combined then at deployment time, you're taking that workload specification, you're taking that baseline YAML file, and frankly, you are adding in the environment specific elements. So you could have a matching file for an environment of type development. I want you to use this particular RDS instance to connect to, and you can point at those. Now, those two in combination actually become executable Kubernetes manifests, and then you can use a platform orchestrator for the more modern platforms, or you could be using something like Argo CD to just plainly and dumply execute that and against kubectl. Yeah, so again, that's what I mean by abstracting without abstracting. You are abstracting, but you're not abstracting them because they know exactly what default baselines are under the hood, and they can go in and change these things if they want. and you can enforce standards. One of the problems with Helm charts is they become their own thing after a while, right? This team is using it like this, and then here, and dev is using it like that, and staging is using it like this. Here you could say like, let's reshare these baseline YAML files across the different environments. Okay, now if you want to take this to the next level, we will the teams go from abstraction without abstracting to what we call an internal developer platform. And I want to explore that as well. If you want, an internal developer platform is really nothing else but the taking all of that you've just seen and all of that, all of the different tooling components and binding that in a pleasant self-service experience. Because one of the next very important things that we are learning is that, and one of the many mistakes that I'm seeing made is that teams only look at that Kubernetes in isolation. A lot of the problems that occur with Kubernetes are not the specific Kubernetes problems, but Kubernetes in combination with its surrounding systems. So your Kubernetes setup in combination with your database, your Kubernetes setup in combination with your file storage. How do you keep all of that in a unified experience? And this is where we're seeing a lot of teams build these internal developer platforms. Now, how are they built? I will not hint at any specific tools. I will keep it very high level. Honestly, most of them at the moment, there are now commercial vendors coming up, but most of them up to now have been self-built. What they're basically doing is that they're taking this here that we're seeing, what we call, and they use it to build what I call a declarative app model. Declarative app model is I'm using an entire description of the application, so I could delete that application and I could actually recreate that. And you think, yeah, that's the classical infrastructure as code, configuration as code, take Helm charts, take some Terraform files, and then you have that. And that is partially true, not completely. That's what we call a static approach. In a declarative application model, which then leads to a dynamic approach to configuration management and platforms, that's a little bit different. So what we've just seen right now is that we have the abstract workload configuration, which is usually handled by the individual contributor. Then we have the normal workload, right? My Node.js application that's containerized, nothing there should change. You're using your, I don't know, Jenkins to build that, push it into an image registry, and then it's available. You describe your configurations in the abstract workload configuration. And then you have a couple of things that usually a dedicated team deals with. That could be a DevOps team, that could be an SRE team, that could be a bunch of backend developers. I actually encourage teams to use usual software developers for that, because make sure that you listen to the needs of the developers. But they deal with the workload profile, the baseline YAML file that you just saw, this one here. And they deal with infrastructure profiles. So an infrastructure profile could be a Terraform file that you could reuse, right? Reusability is a big thing. It could be a cross-plane file. It could be Pulumi. It could be CloudFormation, whatever, drivers. And then the last little bit that they usually govern is what we call resource matching. Resource matching is the saying for a dev environment, please use this infrastructure profile, this database, please use the following workload. So you're making sure that if the developer who really just has to deal with this here commits something through the pipeline, then it knows exactly, for dev, I need to use this RDS instance. For staging, I need to use this one. And that also gives you an additional ease of use for the whole setup. Now, if anything changes here, that should be represented as code. teams usually use a platform orchestrator to read all of that and then dynamically do literally what we've done here. Take this, apply it to this, get the executable manifests, and then sync that to the cluster. So platform orchestrators could sync that directly. They could use something like Argo CD to do that. What you get is the running application, and you get the actual representation of the manifests and the infrastructure as code. All right, now how does that actually fit together here with the toolchain? All of that together is then what we call a dynamic internal developer platform. For the flow of the developer, not much changes. You have your IDE to code, you have your version control system to merge, you have your CI to build. And the platform orchestrator is basically taking all of that input, crunches the input, makes sure that all of the configs are done the right way. The abstraction is actually transferred in something that is executable for Kubernetes, but also for the rest of the infrastructure. And then there are usually a couple of platform interfaces. Some use APIs, some use GitOps, some use UIs, CLIs, observabilities. Some take a service catalog and wire it up the platform orchestrator. With the infrastructure combination, what you actually get is your deployed application. All right, so that was a huge amount of information. I want to quote Kelsey Hightower, the celebrity DevRel at Google. Kubernetes is a platform for building platforms. It's a better place to start. It's not the end game. That is definitely true. We've learned that high-performing teams, it's all about configuration management. Separate out environment agnostic from environment-specific elements of the configuration. That makes your life a lot easier. Standardize wherever possible. Abstract without abstracting, right? Give people higher level abstractions so they don't need to go into all the nitty-gritties of the Helm chart, but make sure they know exactly, like keyword observability, they know exactly what combination of code files actually lead to the final representation that gets executed. Do not think about Kubernetes in isolation. Think about Kubernetes as one component in the larger picture of your cloud architecture, because you will need to make sure that dev connects to the right stuff, staging connects to the right stuff, and configuration drift is the key driver in the change failure rate. And think about using something like a declarative application model that tells you exactly how to use this abstraction and resolves it against infrastructure profiles on an environment to environment basis. With all of that together, right, is what we call a dynamic internal developer platform, which gives you golden paths for your developers. And that is what I see in a lot of the high-performing teams at the moment. To be frank, this is the forefront of how the industry is using this at the moment. And don't get nervous if you're not there yet, right? My reading is that the majority of teams will be there in 5 years, but keep these design principles at the back of your mind as you're approaching that. There was a lot of information. I hope it was helpful. I encourage you to visit platformengineering.org, participate in the Slack channel, visit PlatformCon. Those are like neutral communities where you can chat about these things. And yeah, now I'm very happy to take questions if there are any.
Yep, and thank you, Kaspar, for the talk. I had a half heart attack because my connection died halfway and I thought the whole webinar was down, but I think it was a good thing that you're also a host. Well, we have one in the Q&A, and I also do want to be mindful of time. I know that the event for at least some of you was 45 minutes, so we're 1 minute short of that, but we're happy to run over 5 or 10 minutes to answer any questions. So feel free to drop them in. You can use the chat or the Q&A. Babu in the Q&A is asking, what about the storage and network on Kubernetes. If you want to elaborate a little bit on that, Kaspar, and then yes, we will share the slides, but don't worry.
Yeah, so yeah, I mean, that's a very specific question. I'm not sure how much we can cover on that today. The storage, again, I think that question was slightly after you saw all of the slides. I encourage people to use the same default profiles and the same approach of giving people default ways of consuming this. Even for things like I don't know, horizontal pod auto scaling. That is something that people should be consuming rather than having to set that up bit by bit. If you have very specific questions around this, maybe you send me an email and we can chat about this in more detail.
Yeah, let us know, Babu, if that answered or you have any follow-ups here. Nikhil was asking about the Slack channel. I just shared it in the chat for everyone if you want to join. Sheer is asking, what are your thoughts on using cross-plane XRDs for the abstract without abstraction?
I like cross-plane. I'm not entirely sure where the tremendous value is if you already have something like Terraform, which I think most of us have. I think cross-plane is what we would refer to as an infrastructure profile. And if you use cross-plane the right way, it's a more beefed up, this is like a little nasty way of putting it, but I think it's like a more modern or slightly different Terraform. But this is like one way for you to actually package stuff for your colleagues if they want to request something, right? Use Terraform, use Crossplane, use Pulumi. They're all a little different, not that much. The reality in most enterprises that I see is that people have everything. They have a little bit of Terraform, they have a little bit of Crossplane, they have a little bit of Pulumi and CloudFormation, and that's probably fine. So yeah, I think it's okay if you don't have anything. You could also start with Crossplane. The community of Terraform at the moment is probably slightly larger.
All right. Any other questions? I
think we will have one from Abisek, if I see that correctly, if I pronounce your name correctly.
Oh, yeah, I might have, that disappeared for me because I dropped out, but you can read it.
No worries. What's the best visualization tool for latency throughput? Grafana is great for CPU, memory, and pods. Honestly, I can't really comment on that. I have not enough experience to actually give you a recommendation of what a good visualization tool would be.
All right. Nikki is asking, one of the things you mentioned was that we need to share with developers the exact set of files. One of the challenges we face is communication. Can you tell us about what works best? That's a good question.
Yeah, so that's a very wide, like a wide field. What I mean by sharing the exact files is that don't get into a habit where people say like, you want an S3 bucket, use the CLI command and you'll get the exact one that we want you to get. And if it's not the right one, well then why don't you set a Jira ticket? That's not very productive, right? And that is actually what leads to trouble. And if you have that, then you can say, well, you need to communicate more, but what exactly do you want to communicate? I want to have a second S3 that is slightly different. And then the next team uses the second profile and is also frustrated. You have the same problem. What I'm actually saying is that you want to have a communication like, hey, we don't want to have, I've recently been working with a company that had 63 different ways of spinning up RDS. All of them were security vetted. right? And for what exactly, right? So communication in that sense means, why don't you sit down with all of your colleagues and say, what are the 4 or 5 profiles we actually need, right? And then if you've made up your mind, then make sure you can still give them the CLI command, but when you give them the CLI response, make sure to pass on the repository where the S3 bucket actually lies. So they can go in and they can see it, and they can see the code representation, and they can say, okay, that's how they did it. Well, I actually want to have a change. I send a pull request to the platform team, mark in the comments, I want to change because of this and this and this and this, right? Then you have both. You have good communication. You don't have frustrated people that have that NLP only 95% works situation. But you get actually the best of both worlds.
Right. So I was following up on the question, but it's not super clear to me about exactly what you're asking about. I have a network file. Network. Oh, I see. Okay, so you missed it. I can empathize with that. So maybe you want to reiterate briefly, Kaspar.
I honestly forgot what the question was about, but maybe
the question was about storage and network on Kubernetes.
Yeah, maybe we, so not to bore anyone, we share my email, kaspar@humanitec.com, and we can chat on it via email.
Mm-hmm. And by the way, I've just seen like 10, 15 of you joining the Slack, so that's great. All right, so Brett is saying, I'm curious if there are best practices for how you see teams managing costs of their solutions using internal platforms. How do you manage utilization or overutilization across teams and product groups of platform resources?
Yeah, that's actually a good one. So one of the things that we see work well is that in these infrastructure profiles, you set resource limits. And you say, hey, you can't go beyond that. If you have a modern setup and you have been able to bake something like role-based access control into your orchestrator, then you can basically set very granular stopping points. So that's one thing, right? Bake resource limits in the defaults that you're spinning up. The second thing is, and that is something that is underestimated, the many teams that I see have an unsustainable way of actually commissioning resources in the first place. So I recently was with a larger retailer, and they were spinning up one new cluster for every environment. Now, if they would be like a bank or the FBI or whatever, I would say, yeah, it probably makes sense. But that doesn't make sense at all if you could also just use one more namespace, right? So enforcing through clever defaults and clever infrastructure profiles, the more optimal utilization of resources is another big driver, right? The same holds true for ephemeral environments. Why do you need to have all of your systems up when everybody is sleeping? And some of the more advanced systems that I'm observing is, first of all, ephemeral environments, if give things a timeout. So you don't have, we've probably all been there, right? It's end of the quarter and your CTO says we need to save resources. So you have one douchebag go through all of the resources and say, hey, what can we sunset? And then send 20 Slack messages, do you still need this? It's better if you build these environment packages and then just build them ephemeral and time them out, right? Sunset them proactively. Yeah, so yeah, long story, but there are a whole lot of things that by just having better discipline in how things are set up and how things are also killed if you don't use them, I bet you can probably save 20–30%.
Yeah, good points. All right, we have a couple more minutes left. If there are any more questions. There's one that quick popped up and off. Otherwise, we can wrap it up here. If there are not any more questions. A couple of seconds left. Last chance, last call. Otherwise, thank you, Sharon. Thank you, everyone else, for joining us and staying until the very end. Great session, as usual. And thank you, Kaspar, for walking us through the presentation. People can find you at Kaspar Official on Twitter.
Find me at cheesy Kaspar Official. Exactly. It's as cheesy as I am personally.
Fantastic. Fantastic. Awesome. And we'll follow up with the slides and everything tomorrow. So thanks, everyone. Have a good day, evening, wherever you are. Bye-bye.
Cheers.